All right, guys, I'm getting started with the notes today. This is actually Learning Target 3, Unit 3. So we're going to go ahead and jump right in. Many real-life problems involve a process called optimization. Finding the maximum and minimum value of some quantity. One type of this optimization is called linear programming. The big idea to the process is called the objective function. We usually use this equation to minimize cost or maximize profit. Limitations in the production process are called constraints. The feasible region is the shaded region that includes all possible solutions to the system. If it is an enclosed region, it is called a bounded region. If it is not enclosed entirely, it is called an unbounded region. Bounded regions are the maximum and minimum value of the objective function always occur at the vertices of the feasible region. Unbounded regions have either a maximum or a minimum value. Find the maximum and or minimum values for each objective function. Okay, so they tell us what our objective function here is. C equals 2x plus y. And these are our constraints, okay? So we are going to start graphing the constraints, but before we graph the constraints, I want to go ahead and get this y by itself. So I'm going to add 2x to both sides. So I get negative 2y is greater than or equal to 2x minus 20. So I need to divide by negative 2. And remember, we have a rule that if we divide by negative, we need to flip the sign. So it becomes y there. 2 divided by negative 2 gives me a negative x, and then negative 20 divided by negative 2 gives me a positive 10. So I am going to graph this one, and I'm going to start at 10. 1, 2. And my slope is a negative 1, so down 1 over 1. I'll just go ahead and continue it up here. It is equal to, so it's a solid line. Okay. And because it is less than, I'm going to be shading on this side of it. Let's go ahead and do the next two. So x is greater than 0. So if x is greater than 0, here is 0 at x. So my line is going to be going vertical line, just going straight through the origin. It's a solid line because it's equal to, and x is greater than, so I'm going to be graphing it, shading it on this side. Y is greater than or equal to 5, so I have another one at 5. 1, 2, 3, 4, 5. Another solid line at 5 because it's equal to, and that one is also greater than, so I'm going to be shading above. So where they all meet here is right in this section. Okay, so this is my feasible region within here where all my possible solutions are. Ooh. Okay, and you can see that it intersects here, here, and here. Okay, so your first step when doing a problem like this is to graph your constraints. Your second step is to identify the vertices, and those are the points of intersection between our lines here. So our first one here is going to be 0, 5. Our second one here is going to be 0, 10. And the last one is 5, 5. Okay, so now with the vertices, I am going to substitute the vertices into the objective function. So here's our objective function right up here. So we need to see what each of those equals. See. Okay, so if I substitute in 0 for x and 5 for y into this equation, I get c equals 2 times 0 plus 5. Well, 2 times 0 is 0, so this one is going to equal 5. If I subbed in 0 for x and 10 for y, 2 times 0 again is 0 plus 10 gives me 10. And last one, x, y, subbing in subbing in 5 for x plus 5 for y. So 2 times 5 is 10. 10 plus 5 is 15. Okay, so now your last step in this problem is you need to identify the max and the min, the largest number of your objective function where we plugged in the vertices here. Okay, so these options here. The largest number we have is going to be your max. So our largest is 15. So that max is at the point 5, 5. And your smallest number is going to be the min. So our smallest number is 5 here. And that point is going to be 0, 5. And that is all you have to do for that problem. All right, so with example 2, our objective function is p equals negative x plus 3y. So I'm going to begin by graphing my constraints. I have 1 at 2. And it is just a vertical line. Solid because it's equal to, it is greater than 2, so I'm going to be on this side. X is less than 5, so 1, 2, 3, 4, 5. Less than, so it's going to be on the left side. And that will continue all the way that way, and then this line will continue all the way that way for now. Y is greater than 0, so I'm going to have y is greater than 0. Horizontal line, greater than 0, so it's going up. So you can see we already have 2 vertices right here. Now last line, negative y is less than or equal to negative 2x plus 12, so we're going to start at 12. We're going down 2, if you need to, put it over 1, so down 2 over 1. Looks like there's going to be another one. And another one. Okay, so going to continue this line, and it is less than, so I'm coming down this way. So they are all intersecting in this area here, my feasible region. Okay, it's got to stop here. So now let's identify our vertices. There's one here, one here. And okay, so that's the feasible region. So it stays within the feasible region if there is a number on the outside. So like here, like you would assume this to be 1, but because it stops there, and that's where my feasible region is, the vertices are just the one that contain the feasible region. So this is why that one does not work, okay? So our feasible region points, vertices are 2, 0, and then 5, 0 here. Then we have 2, 8, and we have 5, 2. Okay, so now we need to take these x and y's and plug them into our objective function, p equals negative x plus 3y. So if I begin by doing that, I'm plugging in 2, 0 first here. So 2 plus 3 times 0. 3 times 0 is 0. We have a negative in front, so this is going to give me a negative 2. And then I'm going to plug in, sorry, this should be p now. So now I'm plugging in 5, 0. And that gives me 0 again right here, and then negative 5 for my answer. Plugging in 5, 2. So it gives me negative 5 here, and then 3 times 2 is 6. 6 minus 5 is going to give me 1. And last one, 2, 8. So 3 times 8 is 24. 24 minus 2 gives me 22. So our smallest number is right here. So this is where our minimum is going to be. Okay, and then our largest number is right here. So this is where our maximum is going to be. And that has followed all of our steps, and that is how you complete example 2. If you guys have any questions, please feel free to reach out. Otherwise, have a great day.